Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 6, Section 2, Properties of Parallelograms. So what we're going to learn today is four theorems that deal with parallelograms, and then in Section 3 we're going to learn converses of some of those theorems. So the first thing I want to show you is a symbol you can use for parallelograms. So parallelogram, writing out the word, we can draw this symbol, and that means parallelogram. So anytime you see that symbol there, it means parallelogram, which means I don't have a symbol for quadrilateral. If I want to say quadrilateral, most of the time you'll just see me write quad. We don't have a symbol for like square and rectangle or things like that, but we do have one for parallelogram. Now, each one of these theorems, I'll go over the theorem and talk about them, but the proof I'll actually save for class. Okay, so the first one says that opposite sides of a parallelogram are congruent. So this will be parallelogram, opposite sides, congruent theorem. So by definition of a parallelogram, they have opposite sides are parallel, and then we can use this theorem if we need to say that opposite sides are congruent. Next, we have a definition, consecutive angles. These are angles of a polygon that share a side. So if I draw a quadrilateral, A, B, C, D, angle B and angle D are opposite, and angle A and angle B are consecutive, because they share a side. Okay, the next theorem we have are opposite angles of a parallelogram are congruent. So this one is parallelogram, opposite angles, congruent theorem. And again, I'll do this proof in class. Now, if we want to find a side, so it says it's a parallelogram, so notice the symbol, which means I'm allowed to assume that opposite sides are congruent, and then by that first theorem, parallelogram, opposite sides, congruent theorem, I also know the sides are congruent. So these opposite sides are congruent, so I can solve for it. I can say that 3x minus 15 equals 2x plus 3. Subtract the 2x, add the 15, x equals 18. And so this one is going to be 3 times 18, 54, minus 15 is 39. And just to do a quick check, this one is 2 times 18 is 36, plus 3 is also 39. And so QR and PS are also equal to 39. So I can write QR equals PS equals 39. Our next theorem, the diagonals of a parallelogram bisect each other. So if I draw any parallelogram and then I draw the diagonals, remember diagonals go from a vertex to any non-adjacent vertex, so there's only 2 diagonals. What this one is saying is that they bisect each other, so that diagonal is bisected and this one is bisected. It doesn't mean all the pieces of the diagonals are congruent, but the 2 diagonals bisect the 2 other parts. So this one is parallelogram, diagonal, bisect theorem. And I believe I have one more. So again, that one will prove. And I will do the system one too, since it's a pretty quick example. So for this one, it tells me again it's a parallelogram. So I know the diagonals bisect each other, so I can say y is equal to x plus 1, and I also know that 3y minus 7 equals 2x. So I think substitution is the easiest way to solve this one. Y is equal to x plus 1, so I can substitute that in, and 3 times x plus 1 minus 7 equals 2x. So 3x plus 3 minus 7 equals 2x. 3x minus 4 subtract the 2x, add the 4, so x equals 4, which means that this diagonal is 5. Y is only one more than that 4, so this is 5. And this is twice x, so this one is going to be 8. And then 3 times that 5, so this will be 15 minus 7, which is also 8. Okay, so we have that BE is equal to ED, which is equal to 5, and we have AE is equal to EC, which is equal to 8. The next one kind of doesn't go with the other ones, at least for a parallelogram, but this one says if 3 or more parallel lines cuts off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if we have more than 2 parallel lines, so 3 or more, and then we have a transversal, and it has to cut congruent parts. So notice what I'm given. I'm given that AC is congruent to CE. Then what I also know is that BD is congruent to DF. So if AC is congruent to CE, then BD is congruent to DF. Okay. This one is a transversal theorem, so if we call this one the parallel lines transversal theorem. We won't use this one too much in proofs. We have one later on when we deal with similar triangles. It's called the side splitter theorem that we use a whole lot more than we use this one about parallel lines. The main theorems that are important are the first 3 about parallelograms. Okay. And that's it for today's video. Thank you for watching. Have a great day. Take care.